perfect. All right, we're going to continue with circles today. We're going to learn a couple of theorems that help us solve problems involving circles. I'm going to write the theorems up on the board so we have them, and then we will erase them and work through some problems. So there's two theorems. It's three theorems, but two of them are the same thing, just one's the converse. So let's start with what we're talking about today, which is tangent. Page 427, we're talking about tangents to a circle. Okay, so here's a circle, we'll call this circle C. All right. A tangent is a line that goes through a circle in one point. And so this is what a tangent looks like. I'm freehanding this, so please bear with me. Okay, so it's a line that touches the circle, but it doesn't go through it. It actually only touches the circle in one point. We call this the point of tangency. Let's call this X. This is the tangent. The tangent is just a line that touches the edge of a circle. We'll call this line M. Now, the radius goes to that point of tangency, and it has a special property. So this is the radius. When the radius touches the point of tangency, these two lines are perpendicular, meaning they create a right angle. So here's our first two theorems. These theorems don't really have a name. You can call them the Tangency Theorem or whatever you want. It's 10-2 point something. I don't know. Anyways, the first theorem is if Cx, I'm sorry, let me get this right. Let me name this line AB. If M is tangent to circle C, then M is perpendicular to CX. Okay, so this is the theorem. If this line is a tangent and it goes through point X, then the two lines form a perpendicular relationship. Okay, the second theorem is the opposite of that, the converse of this. I'm not going to write it down. So this says if M is tangent to circle C through X, then the line M is perpendicular to CX, the radius. Okay, vice versa. If the radius is perpendicular to this line, then that line is a tangent. Okay, so I'm not going to write down the converse. It's in your book on page 427. Okay, so the first thing, and the most important thing about tangents for this lesson is that it creates a 90-degree angle with the radius. All right, now there's not just one line of tangent. There could be two lines of tangency. Let's look at another one here. There could be infinite lines of tangency. All right. I'll call this line F. Okay, so here we have F, and let's call this point P. The same thing is true This here would be a 90-degree angle. Okay, now here's the other property we're going to discuss. If we have two tangent lines going and they intersect each other, we'll call this point y. If these two lines, which are tangents, intersect each other, then this segment here is congruent to this segment here. So if F and M are tangents, then their intersection makes line PY congruent to line segment XY. So basically, this segment is congruent to this segment. All right. Now, because this is a radius and this is a radius, these are also congruent. But that's if the radius is equal to itself, then they're equal to each other. Okay. So these are congruent because they're the radius, and these are congruent because of this theorem. And the theorem that I'm talking about right now is on page this is theorem 10-2, segment tangents to a circle theorem. It's on page 429. So the theorems we're looking at are on 427 and 429. All right. So this is all the information we need to have in order to do the problems for today. All right. So just to recap, if this is a tangent, it creates a 90-degree angle with the radius. If there's two tangents, then they create two congruent line segments, PY and XY. Okay? All right. So we're going to go through some problems, and I think I have 6 problems. Some of them are fast, some of them are long. And I'm actually doing the problems from the book, so you can follow along if you have your book. These problems are going to be on page 433, starting with number 16. Do I have any questions so far? All right, we'll start with number 16. Here we have a circle, circle T. Trying my best to recreate these triangles and circles. Okay, we have circle T. This is A, B, C, and D. A, B, C, and D. And it's telling us that the segments A, B, and C, D are tangents. So this is a tangent, and this is a tangent. Which means that, hold on. Oh, Renee is outside. Does anyone have Renee's number? Phone number? Christina, can you text her and tell her she has to use a PGCPS account to get in here? Because I'm recording. It won't let her in. Thank you. Oh, she's in. Never mind. Hey, Renee. All right, so this is actually question 16 and 17. But the only thing we know is that A, B, and C, D are tangents. So if these are tangents, that means that this is a right angle and this is a right angle. Even though this looks like, and this is one of the common mistakes that we make when we're doing these types of problems, we sometimes think these interior angles are right. They might be, but they are not. That's unknown. We don't know what that angle is. We do know that this is a right angle because this is a tangent. We do know that this is a right angle because this is a tangent. Okay, so the first problem is asking us to find AB. Oh, I'm sorry, I didn't put all the dimensions on here. So this is 6 and 6. So we know that this is 6 and this is 6. And this is 4x plus 4 degrees. And we know that this is 8x plus 2 degrees. Okay, so the first thing you need to know is that these are 90. If these are 90, then we can use the Pythagorean Theorem to find this missing side. This missing side is not the hypotenuse, even though it kind of looks like it, the way I drew this. This side is B, A, and then this is the hypotenuse here. And again, that's the confusing part. This is the hypotenuse. So to find AB, we're looking for AB, and we're also looking for angle TDC. So let's find AB first. And this is just a right triangle. We're solving for B. So this is A squared plus B squared equals C squared. And here we know C and A are 6. 6 squared plus B squared equals 6 squared. This is 36. This is 36. Wait, did I mess this up? I did. This whole side is not 6. It's just this piece here that's 6 from here to here. Okay. So to find, oh, duh. Okay, so if this is 6 here, it's the radius, then this piece here has to be 6 as well because it's also the radius because these two are congruent. So this is actually 12, okay, which is the hypotenuse, 12 squared. Did I lose anybody there? You guys see what I did? Okay. All right, so 36 plus B squared equals 144 minus 36 minus 36. So B squared equals 144 minus 30 is 114 minus 6 is 108. Find the square root of both sides and you get B equals the square root of 108. Which is about 10.4. So the problem asked us, oh, all right, it doesn't want it as an approximation. It wants it as a simplified rational number, or a simplified irrational number. So B is equal to the square root of 108. And then we have to simplify 108 to its smallest terms. 108 is 2 times 54, which is 2 times 27, which is 3 times 9, which is 3 times 3. The 2's and 3's pull out, so this is 3 times the square root of, square root of 3, and then 3 times 2 is 6. So the answer is 6 times the square root of 3. That's how it wants the answer. All right. Any questions about that? No. All right, let's do the next one, which is to find the measure of angle TDC. This one's pretty simple, actually. We're looking for this angle here. And we know that the sum of these 3 angles inside this triangle is 180. So we can set up, and we know this is 90. So 90 plus this has to be 180. So let's write out the equation. 90 plus 4x plus 4 plus 8x plus 2 equals 180. And then we just simplify. 90 and 4 and 2 is 96 plus 12x equals 180. We solve this and we get x equals 32. Wait. So I found x. I did not find the angle measure. I know x is 32. Now I need to plug 32 into this and I'll find out that angle measure. Is that right? I'm sorry. I'm confusing you guys. X is not 32. I actually have to solve this, sorry. Minus 96, which is 84. 12x equals 84. 84 divided by 12 is 7. X is 7. If you plug 7 into here, you get 32. So now 4x plus 4 is 28 plus 4 is 32. So it's 32 degrees. Okay. I'll pause here if you have any questions about either of those two. We are 1/3 of the way through the problems. Okay. That was 16 and the blue one was 17. Numbers 17 and 16. So now we're going to go on to 18. Alright. Number 18. We have a circle, center G. Okay. And this one is 2x minus, wow, I made that look bad, but let me do this over. It's even worse. Alright, whatever, we're going with it. Just pretend they're touching. Okay. Center G. And we have x minus 2, 2x minus 4. And x plus 7. Okay, and our job is to find dg. That's df. That's this length here. Okay, now here's a couple things. We know that these are right angles because they are tangents. We also know that this is congruent to this because they are radii. We know that this is congruent to this because of the second theorem we learned, the tangents of a circle theorem. Okay, so basically what we're going to do is we're going to use these two here to find x, and then we're going to use x to plug it in here to find out what GF is. And once we find out what GF is, we know it's the same as dg, so we found it. Okay, so first thing we got to do is set this equal to this because they're congruent. So 2x minus 4 equals x plus 7. We're going to solve for x, and that's going to give us our value. Plus 4 is 11, minus x, and we get x equals 11. Okay, x is 11, which means that I can plug 11 into here. And I know that GF equals x minus 2, so therefore it is 11 minus 2, so it is 9. Now, if GF is 9, which is the radius, then we know GD is also 9, which is the radius as well. Questions? Okay, moving on. Number 19. We are halfway through. We have a circle that is inscribed with a polygon. Okay, looks kind of like that. J, L, N, Q. J, L, N, Q. K, M, P. figured out how to do this easier. I'm sorry guys, I'm not good at drawing these circles. Let's draw the quadrilateral and then draw the circle inside. There we go, that's better. J, L, and Q. And then K, M, P, R. And our job is to find the perimeter. And we know that that's 2, 5, 3. 2, 5, 3, 7. Okay, so our job is to find the perimeter of this. Now we're going to use what we know about the second theorem we learned. Okay, so if these are tangents, that means that this is congruent to this. So this is also 7. Okay, this is congruent to this, so that means this is 3. This is congruent to this, so this is 5. And lastly, this is congruent to this, so this is 2. Now we have all sides of the parallelogram, of the quadrilateral. So we just add them all up. 3 plus 3 plus 5 plus 5 plus 2 plus 2 plus 7 plus 7 is 6 plus 10 plus 4 plus 14, which is 16 plus 18, which is 34. That one's pretty simple. Any questions? No. Okay, moving on. You guys don't have any questions? All right, so there's 2 more. These 2 are a little more challenging. So they'll take a little bit more time for you to do, but they're the same principles here, okay? Number 20. All right, draw the triangle first, George. Okay, there's one circle, and then G is down here. There's the other circle, and then G extends to there. GH. D. ABSE. Okay, and we know a couple of pieces of information. We know that this is 29. That is from F to E. And we know that DC is 32. And we know that GE is 9. Okay, and our job is to find AC. C is at the end there. All right, so to find AC, we need to know the length of AB and then add it to the length of BC. All right, to find BC, we need to know the length of EC, right? So let's do that. We need to find the length of EC. EC is the long leg of triangle, right triangle GEC. All right. So we're going to set up Pythagorean theorem. This squared plus this squared equals this squared. So 9 squared plus EC squared equals 32 squared. And we're going to get 81, and 32 squared is 1024. We're going to subtract 81, and we're going to get EC squared equals 943. We're going to take the square root of both of those. Let's hope it gives us a perfect square root. It does not. Yeah, so 943. All right, that's okay. We're just going to leave it as a oh, that's why. I see what I did. 32 is not the hypotenuse. 32 is only from D to C. There's a little unknown here, which we actually do know. This is the radius of the circle, so this is actually 9 as well. They didn't give us that information, but it is what it is. Okay, so this is actually, the hypotenuse is not 32, it's 32 plus 9, which is 41. So 41 squared is 1681 minus 81, which would be 1600. Square root of 1600 is 40. So now I know that EC is 40. Okay. Now, do you see this circle here with these two long tangents? Well, these two long tangents, AC is congruent to FC because they are tangents of this circle, okay? So we ignored this circle for this part, but now we're gonna look at this long tangent, which is 29 plus 40, which is 69. So therefore this here is also 69. So AC is 69. You're going to have a problem almost identical to that, but it'll obviously have different numbers. Any questions? Okay, this last problem I actually spent quite a bit of time trying to figure out, and the solution is actually much more simple than I thought it was. Here it is, number 22. We're skipping 21. Here we have a right triangle. Okay, the right triangle is F. And ABC. And the only thing we know is that these three sides are tangents here, here, and here. And that AB is 10. That's it. Okay. And our job is to find the diameter. Oh, I'm sorry. The diameter is 8. And our job is to find the perimeter of this triangle. Okay. We don't know this side and we don't know this side. So we can't use the Pythagorean Theorem to find a missing side because we only have one side known and we need at least 2 to find that. Okay. We know the diameter is 8 and we know the diameter goes at a right angle to each of the points of tangency. So I'm going to draw that. Okay, now this is where I couldn't figure it out earlier until it finally clicked. What shape is this? This right here. What shape is that? I'm waiting. Yes, it's a square. How do I know it's a square? Well, it's got a right angle, a right angle, a right angle. So this has to be a right angle, right? And also the side lengths are the same. So it's got 4 sides, 2 of which are 8, so therefore the other 2 have to be 8. So this is where I messed it up. So keep this in mind. This is a square, and this is 8 and 8. We'll get to there in a second. Now, I don't know the split here and here, right? But now I do. I know that this is, oh, I'm sorry guys, the diameter is 8. So what are my radius? See, I'm messing it up. The diameter is 8, so my radius has to be 4. Not 8. Okay, so that means that this is 4 and this is 4. Okay. So if this is 4, what is this? This is 4. What is this? 6. Good. Because 10 minus 4 equals 6. Good. All right. Now, if this is a tangent and this is a tangent, isn't this congruent to this? Yes. So if this is 6, this is also 6. Okay. Now, we can't use this number 4 to find this because we don't know what this whole side is, like we did this side. The same thing here. But what do we know about this and this? What do we know about this and this? They're congruent, correct. So I do know that this equals this, right? So I'm just going to name this x and x. All right, now I can use this information in the Pythagorean theorem and solve for x. And once I find the value of x, I can add them up and get the perimeter. So that's what I'm going to do. I'm going to use the Pythagorean theorem. So the Pythagorean theorem says a squared plus b squared equals c squared. Okay, what is a? A is 10. I'm going to break it up into 4 plus 6. It's the same thing as 10, right? All right. You'll see why in a second. What is b? Correct. 4 plus x. And what is c? 6 plus x. Good. Now I'm going to have to do a little bit of foiling. Well, this is just 100. 10 squared is 100. Okay. 4 plus x squared, and you can foil this out if you want, but just believe me, is x squared plus 8x plus 16. And x plus 6 squared is x squared plus 12x plus 36. Okay, now we have an equation we need to solve for x. I'm going to start by subtracting x squared from both sides. And those x squareds go away. I'm going to combine 116 to get 116. And I'm going to subtract 8x from both sides. And I get 4x. Okay. Now I'm going to subtract 36 from both sides. And I get 4x equals 80. So x equals 20. Okay, so I found the value of x. I haven't answered the question. The question's asking me to find the perimeter of this figure. So now I know what the x's are. So this is 20, and this is 20. So now I'm going to add these up. 4 plus 20 plus 20 plus 6 plus 6 plus 4. All right, so I end up with 2 6's. I'm sorry, this is 26 and 24 and 10. 26 plus 24 plus 10, which equals 60. And that's the answer to that question. And that